This lesson, this lesson is called L'Hopital's rule. Now, L'Hopital's rule just became a part of the Calculus AB curriculum 2 years ago. It's always been a part of the Calculus BC curriculum. There's no particular reason because it's real easy. It's easy. And in fact, it really will help you a lot when you find limits. Well, why didn't we do it when we did limits? Because you didn't know how to do a derivative then. L'Hopital's rule does involve limits. I mean, it does involve limits. It does involve derivatives. So let's just take a look here. At the onset of our study of derivatives, we used a limit to find a derivative. This right here is in your stuff you must know cold. If you remember, the definition of the derivative of a function was given by the following limit. The limit is as h approaches 0 of f of x plus h minus f of x over h. In the same sense, L'Hopital's rule uses derivatives to find limits of certain functions, in particular limits that are of indeterminate form. You remember all those problems where we would substitute in and we'd get 0 on the top and 0 on the bottom, and we'd say, well, that's indeterminate form, so that means we've got to do something else. Welcome to something else. Now, you know that you could factor and simplify and take limits. That was one way. You could also rationalize the numerator. That was another way. The L'Hopital's rule is just another tool in your toolbox to help you find derivatives, or to help you find limits. These are essentially all the different ways you can come up with indeterminate form. In our study of limits, we encountered limits of functions that were of indeterminate form. When direct substitution is applied to evaluate a limit, results of 0 over 0, infinity over infinity, and so on are referred to as indeterminate form. Now, I need you to be very careful when you do L'Hopital's rule. And I need you to do it exactly the way I show you, because if you don't, you will not get credit on the exam, even though you think, I know how to do it. But there's a very specific way the graders want it written. And I have a sheet for you that we're going to look at toward the end of the period where you're going to actually look at some student answers and you're going to decide, did they get the points for the work that they did? Let's take a look at an example of those from earlier in the year and remember the methods we use to find the value of these limits. Now let's take a look at that first one. Try to evaluate the limit below by direct substitution. Now, if we do direct substitution into the numerator of x equals 3, what do we get? 2 times 9 is 18 minus 3 is 15 minus 15 is 0. Denominator, 3 squared, 9 minus 3, 6 minus 6, 0. We said, okay, that's indeterminate form. We cannot solve this limit by direct substitution. So one of the ways that we were able to do this problem was we were able to factor. I want you to do this one. I want you to factor the numerator and factor the denominator. Have you got that numerator factored? How's it go? 2x plus 5 times x minus 3. That's 2x squared minus x minus 15. Yep. Denominator. That's x squared minus 3x plus 2x minus it. Perfect. And then what did we do after that? And then we were able to do direct substitution and take our limit. Direct substitution is going to give us what? 11 over 5. 2 times 3 is 6 plus 5 is 11. And 3 plus 2 is 5. Okay. That should be just as easy for you Now, let's go to the next box. L'Hopital's rule makes finding a limit of this form easier by using derivatives. Now, I'm going to write L'Hopital's rule formally here, and then we're going to actually apply it to that problem, and you'll see how easy it really is to work with. So for those of you watching the video, I'm going to stop while I write, and then I'll turn it back. Here's the first part of it. If the limit as x approaches c of f of x equals 0 and the limit as x approaches c of g of x equals 0 and the limit of f prime of x over g prime of x equals L. So that's one situation. And this is really easy once we actually get to doing problems, I promise. Or, now, on the video, I'm going to stop again, I'm going to erase this, and I'm going to put the rest of the definition. Here's the second scenario. If the limit of f of x as x approaches c equals plus or minus infinity, and the limit of g of x as x approaches c equal plus or minus infinity, and the limit of f prime of x over g prime of x as x approaches c equals L, then the limit as x approaches c of f of x over g of x equals L. Now all that just looks Greek and awful and Chinese or whatever language you don't speak. All of them. Now we're going to use L'Hopital's rule to find this limit. In order to use L'Hopital's rule, you have to show that the limit of that function as is when you do direct substitution gives you indeterminate form. But the first thing I'm going to do it wrong. So I don't want you to write this down. Equals. I'm going to put in 3. Well, we did that up earlier, didn't we? And we got 0 over 0. I'm going to tell you, if you write that down, the graders will not give you credit. Why? Because that's not the limit. So if you write down that that limit equals 0 over 0, even if you write down, so L'Hopital's rule applies and you use L'Hopital's rule, you will not get full credit. Okay? So here's what you have to do. You have to apply the rule as written. You have to show the limit as x approaches 3 of the numerator equals 0, and you can write this down. The limit as x approaches 3 of the denominator equals 0. So L'Hopital's rule applies. That's how you're going to get the first point of your credit. We'll pick up after lunch. You have got to write this. If you don't, and then you go and use L'Hopital's rule, that would be on a free response. It would be worth 2 points. If you don't write that thing that I've got circled in red, you will not get the first point, even if you do the limit correctly using L'Hopital's rule. Now, so how do you use it? I'm going to erase this, and I hope the eraser works with me this time. If we go back to when we had 0 here and 0 here, on this particular problem right here, the limit of the numerator as x approaches 3 equals 0, and the limit of the denominator as x approaches 3 equals 0. Now, what we're going to do is we're going to do this piece right here. We're going to take the derivative of the numerator, and we're going to take the derivative of the denominator. And we're going to evaluate that as x approaches 3. So, now we're going to say, you can write this down. The limit as x approaches 3. I don't want you trying to use quotient rule. That's not what this is. L'Hopital's rule says you are taking the derivative of the numerator and the derivative of the denominator. I turn the heat up. I'm cold too. What is the derivative of this numerator? What's the derivative of the denominator? Now, if we do direct substitution right there, what are we going to get? And that's what we got. It is so much easier. L'Hopital's rule is so much easier than doing other things, especially when you have polynomials. What you have to do is you have to explain why you are using L'Hopital's rule. Yeah. Next page. Two other limits that we learned earlier are also of indeterminate form. These are on your stuff you must know cold sheet. What we did to determine those before was we did them graphically. If you remember, we graphed them on our calculator and we blew it up and we looked as x approached 0 and we saw that those limits were 1 and 0. Now, we're going to use L'Hopital's rule and actually see another way that they're actually equal to 1 and 0. So, L'Hopital's rule. You cannot just arbitrarily say, oh, think I'll use L'Hopital's rule. It doesn't work that way. You're eyeballing this and you're doing direct substitution. The sign of 0 is 0, and then the denominator would be 0, so you would get indeterminate form. So you're going to write this. The limit of sine x as x approaches 0 equals 0. The limit of x as x approaches 0 equals 0. So L'Hopital's rule applies. Now you're going to write the limit as x approaches 0. We're actually going to apply L'Hopital's rule, which means we take the derivative of the numerator, and then we take the derivative of the denominator. What is the derivative of the numerator? What's the derivative of the denominator? Do direct substitution. What's the cosine of 0? 1 divided by 1. And that, ladies and gentlemen, is L'Hopital's rule. Now, let's do the other one. I'm not going to write down this red line. But if you do direct substitution, 1 minus the cosine of 0, what is the cosine of 0? So 1 minus 1 is 0. Divided by 0, you have indeterminate form. Therefore, L'Hopital's rule applies. The limit as x approaches 0, what is the derivative of that numerator? Sine x over 1. Direct substitution. Sine of 0 is 0 divided by 1 is 0. I like L'Hopital's rule. You think, why was this in the Cal BC, Cal 2? I don't know. It's plenty easy for Cal 1. Okay, here we go. Yeah, exactly. Exactly. Use L'Hopital's rule to find the values of each of the following limits. Again, you know you got to use it because of the section we're in, but you got to write it down. And I quit. What is the cosine of pi over 2? 0. So the numerator is 0. So you're going to write the limit of opposite of cosine x as x approaches pi over 2 equals 0. The limit of x minus pi over 2 as x approaches pi over 2 equals 0. So L'Hopital applies. You don't. You just write La Hospital and leave out the S. That's the only way I could ever remember how to spell it. Oh yeah, I don't ever put the little funny thing on the O. No. Yeah, no, that's fine. Okay. So now let's do L'Hopital's rule. L'Hopital's rule says then that the limit, I really wish y'all would be a little respectful here. Let's go. What's the derivative of that numerator? I'm sorry? Positive sine x divided by 1. Sine of pi over 2 is 0. 0 divided by 1 is 0. 0 divided, oh, I thought you said 0. Did I misunderstand? All right. We're all right? Let's keep going. Middle one. We're going, you always do direct substitution first. Always try that first. If x is 0, 7 times 0 minus the sine of 0. What's that equal? 7 times 0 is 0, minus the sine of 0. So I know the limit of the numerator is 0. Uh, 0 squared plus the sine of 0. Well, that's 0 again, isn't it? So I know L'Hopital's rule applies. Have you got this part? I'm going to erase it. So now we're going down and we're going to say, all right, then the limit as x approaches 0 of, now let's take the derivative of the numerator. What are we going to get? Is it minus cosine x or plus cosine x? Minus, 7 minus cosine x over 2x 3 cosine 3x. Numerator. 7 minus cosine of 0, because cosine of 0 is 1, so 7 minus 1. 2 times 0 plus 3 times the cosine of 0, and the cosine of 0 is 1. On multiple choice, they're not going to look at things that you write down. So if you just look at it and think, okay, it's 0 over 0, you don't have to write down, so L'Hopital's rule applies if it's multiple choice. So that's where you hope the multiple choice, you hope you have a L'Hopital's rule. Last one here. The limit as x approaches 0 of sine x cosine x. What is sine of 0 times the cosine of 0? Because it's 0 times 1. And the limit as x approaches 0 of zero plus sine of 0. you say, so L'Hopital's rule applies. How are we going to take the derivative of that numerator? Product rule, good. Derivative of the first. So cosine x times the second is cosine x. You okay with that? Derivative of the first is cosine x times the second is cosine x, so it's cosine squared x, plus the derivative of the second times the first. Did I do too much in my head? Denominator, derivative. All right, let's go. Cosine of 0 and then square it. What do you get? 1. Sine of 0 and then square it. That's 0. 1 plus 2 times the cosine of 0. What do you get? It's a pretty nice way to do limits. If you got indeterminate form, I'm not worried about that other crap. I'm going to L'Hopital's rule. Okay. Now, here's the neat thing. I want you to look at this one. What if this had ended up with indeterminate form? You can do L'Hopital's rule again, and again, and again, and again. You could keep doing it until you get a limit. Let's take a look at this one. Here we go. No, we're not. You snap. 2 cosine x minus 2. Quit. Over. Let's see. Let's see what that is. 2 times the cosine of 0. That'll be 2 times 1, which is 2. Minus 2 times the cosine of 0. We get a big fat goose egg right there, don't we? Denominator, limit as x approaches 0 of 1 minus cosine x. That gives me 1 minus the cosine of 0. So L'Hopital's rule applies. All right, let's go apply it. So I have the limit as x approaches 0. Help me out with some derivatives here. My brain's mushy. Derivative of cosine is minus sine, so that'll be plus 4 sine 2x over. Now, if I were you and I were working this problem, here's what I would do. I'd put equals, because I would think, okay, one time it will be fine, right? The sine, yeah, you think sine of 0 is 0. Negative 2 times 0 is 0, plus 4 times the sine of 0. Oh, that's 0. Well, snap, and the sine of 0 is 0. And as soon as you see its indeterminate form and you know the graders are going to have an absolute fit, you erase that. Now, you don't need to go through the limit of the top equals 0 and the limit of the bottom equals 0, so L'Hopital's rule applies. You don't worry about going through that again. What we're going to do is we're going to go right down below it and we're going to apply the dang thing again. What's the derivative of negative 2 sine x? Negative 2 cosine x plus 8 cosine of 2x divided by. Now I know this is going to be okay because I've got cosines going to 0. We're going to work. This is going to work. Negative 2 times the cosine of 0 plus 8 times the cosine of 0 over the cosine of 0. I sure hope that's 6. Also notice, if you do not put your limit notation, you will not receive full credit. Snap, we got 2 more pages? Yeah, I'm all right. Yeah, yeah. Okay. Now, let's remember how we calculated limits at infinity. Let's take a look back at this one. We did this 2 different ways as x approaches infinity. Remember, as x approaches infinity, what you're finding is horizontal asymptotes. And you learned in pre-cal how to do that. Do you remember the rules from pre-cal? It said you look at the coefficient of the term with the biggest exponent in the numerator and in the denominator. Biggest exponent in the numerator, that's an x squared. Denominator's x squared. Negative 3. Yeah. Since the degree is the same in the numerator and denominator, I just use those coefficients. And you get 4 over negative 3. That's what you learned in pre-cal. But then earlier this year, you learned why that worked. And if you'll remember, we did this. The limit as x approaches infinity. We said, well, x squared is the biggest exponent that you got in the denominator, so we're going to divide every term in that whole mess by x squared. And so it looked like this. I hope this is ringing a few bells. Or has your doorbell just died? You just had a door knocker, and it's came off the hinge too? Okay. Limit as x approaches infinity. We did this last semester, and what we did is we looked in the denominator and we found the term with the biggest exponent, okay? And what we're going to do is we're going to divide every term in that whole rational expression by x squared. And then we're going to simplify each one of those fractions. What's that first fraction? Minus and then you said, oh, as x approaches infinity, what does this do? How small? Closer and closer to 0. Right, infinitely small, closer and closer to 0. So that approaches 0. What does this do? As x approaches infinity, that approaches 0 as well. 4 minus 0 over 0 minus 3.
That was last semester. I remember doing it, but it feels a lot longer than that.
Yeah, it was last semester. Now, let's see what you think of using L'Hopital's rule. Here we go. Yes, we're going to write all that stuff. Limit as x approaches infinity of 4x squared minus 5x. Well, that's infinity. Infinity minus infinity is not 0. It is still infinity.
Wait.
I don't. Remember, infinity is not a number. Infinity is an idea.
What's variable? What's negative? Yeah. Technically, all numbers are made up.
Look, if I take a huge number and I square it, and then I subtract the original number, I'm still huge. What I have here is infinity over negative infinity. That is indeterminate form. L'Hopital's rule applies. You got that? Now, let's use L'Hopital's rule. The limit as x approaches infinity. What's the derivative of the numerator? What's the derivative of the numerator? Over. Now, which one am I? Yeah, no, so you have to do it twice. Because here, don't I still get indeterminate form? Do it again. What's the derivative of the numerator? Over. That's negative 4/3. Yeah. So you got 3 ways to do the same thing. Pre-cal, dividing by that x squared, and L'Hopital's rule. Same thing. Okay, we got one more here. Use L'Hopital's rule to find this limit, and then using your knowledge of horizontal asymptotes from pre-cal, explain why the result is what it is. First, let's do the pre-cal. Biggest exponent in the numerator? 2 off an x squared. Biggest exponent in the denominator? 3 off of an x cubed. Bigger exponents in the denominator. What's that tell us about the horizontal asymptote? Equals 0. Look, if I've got this, isn't that the same as this? You look at this right here. As x approaches infinity, this is going to be 1 over 1, 1 over 10, 1 over 100, 1 over 1,000, 1 over 1,000,000, closer and closer and closer to 0. So this better have a horizontal asymptote of y equals 0, meaning it better, as x approaches infinity, better have a limit of 0. So we do it in our heads. Every term's got an infinity in it. So you're not going to have infinity minus infinity is 0. You're going to get infinity over infinity, and you have to write out your reasoning, okay? That first step, I'm not going to write it down, but you have to. So let's go ahead and apply L'Hopital's rule since we know it exists. What's the derivative of the numerator? 10x minus 1 over Do I still, can I apply L'Hopital's rule again, or can I just take the, do direct substitution and be done? I'm going to do it again because I'm still going to have infinity over infinity. So I got to do it again. 10 over, I will not get infinity over infinity this time because I have a constant in the numerator. What am I going to get? Because I get 10 over infinity, which means 10 over 1, 10 over 10, 10 over 100, 10 over 1,000, 10 over 1,000,000, which approaches 0. This last page is 4 practice problems. Here we go. Is it that bad? I'm sorry it's that bad. I'm sorry your brain's tired. Mm-hmm. Yeah, we're doing this. What's the matter? Here's the question. Since it tells us to use L'Hopital's rule, do I have to write down the proof of why I have to use L'Hopital's rule? No. On your homework, yes. On your homework, yes. You hear me? On your homework, you're going to write it because you have got to train yourself to do it, because if you don't, you won't, and you will lose the points. End of discussion. Go. What's the derivative of the numerator? Remember how to take the derivative of natural log? It's 1 over that times the derivative of that. Derivative of natural log is 1 over 2x times the derivative of 2x. What's the derivative of the denominator? X to the negative 1/2. We got to clean that up. So well, we got 1 over x divided by 1 over root x. What's that equal? Yep. Caden, you want to go through that? Remember, dividing by 1 over x, x to the 1/2 means times x to the 1/2 over 1. So you get x to the 1/2 over x, which leaves you with 1 over root x. You get 0. Next one. Well, that just looks ugly, but let's see what we can do. The limit as x approaches 1/2. How are we going to take the derivative of that numerator? Product rule, good. Product rule and chain rule. One thing that I'm worried about, I'm afraid you're going to want to do the quotient rule. L'Hopital's rule is take the derivative of the numerator, take the derivative of the denominator. All right, derivative of the first, 1 times the second, plus the derivative of the second, times the first. All right, Let me double check that product rule. Derivative of the first is 1 times the second, so that's 1 times cosine pi x. Plus the derivative of the second, that's minus sine pi x times pi times the first. Denominator. What's the derivative of e to the x? E to the x. What's the derivative of root e? 0. E is a number, and the square root of a number is a number, and the derivative of a number is 0. Remember, e is like 2.718, so it's just a number. And the derivative of a constant is 0. Cosine of pi over 2 minus, I don't know why I put that in parentheses, didn't really have to. Sorry? Oh, I wrote, oh, yeah. Is that better? Yeah. Cosine of pi over 2 what have we got, 2 more? We got 2 more or 1 more? 2 more. Snap. Oh, this one. I wrote 2. Yeah, I wrote pretty big, didn't I? All right. It said to apply L'Hopital's rule, so we'll apply L'Hopital's rule. You know, I really wish I would have. What's the derivative of the numerator? Minus e to the x over derivative of a log, of a natural log. That's negative e to the x times 2 minus e to the x over. Did I write that down right? What do I get? 2 minus 1. One more. Here we go. Okay, again, I'm going to apply L'Hopital's rule. Derivative of the numerator. What am I going to do? Product rule. Derivative of the first times the second. Guys, stop, please. Derivative of the second is minus sine times the first. The denominator, I'm also going to use product rule. Derivative of the first is 1 times the second. Derivative of the second is cosine x. Did I screw that up anywhere? Now we'll do our direct substitution and see if we have to apply L'Hopital again. I don't think we will though. Cosine of 0 is minus 0 over sine of 0 is plus 0 plus 1 is 1 times the cosine of 0 is 1. Is that it? Remember, no, I don't want to say that, never mind. When you do direct substitution to take a limit, if you get indeterminate form, you do not leave 0 over 0 or infinity over infinity. You erase that as fast as you can. And then you go and write the limit of the numerator equals whatever, the limit of the denominator equals whatever, so L'Hopital's rule applies, then go do it, okay? And it is not the quotient rule, it's the derivative of the numerator and the derivative of the denominator. Don't start using quotient rule. Now, okay. That's all for the video. Annabelle and Malia, hope you get well real fast.